Today we are going to talk about solving fractional equations. Equations involving fractions or rational expressions arise frequently in mathematics. The key to working with them is to manipulate the equation, typically by multiplying both sides of it by some quantity that eliminates the fractional nature of the equation. The most common form of this practice is cross-multiplying. Use the technique of cross-multiplication to solve each of the following equations in exercise number 1. I want you to try these two equations on your own using cross-multiplication and see what you come up with. Pause the video and then come back when you're finished to see how you did. For exercise number 1A, we want to take 5 and multiply it by 4x plus 5, and we want to make that equal to 2 times x minus 1. When we multiply 5 times 4x plus 5, we get 20x plus 25. This is equal to 2 times x minus 1, which results in 2x minus 2. Now subtracting 2x and subtracting 25 from both sides gives us 18x equals negative 27. Then dividing both sides by 18, we find that x equals negative 3/2. On part B of exercise number 1, we have to take x plus 1 and multiply it by x minus 6 and make that equal to 2 times 2 minus x. When we FOIL out the left-hand side of the equation, we get x squared minus 6x plus x minus 6. The right-hand side of the equation, when we multiply it, we get 4 minus 2x. Because this is a quadratic equation, we want to make everything equal to 0. So we want to subtract 4 from both sides, and we want to add 2x to both sides. So our quadratic equation that we need to solve is x squared plus 3x minus 10 equals 0. By factoring, we get x plus 2 times x minus 5 equals 0. And with the zero factor property, this tells us that x plus 2 equals 0 or x minus 5 equals 0. By solving those two small equations, we find that x equals negative 2 and x equals 5. Notice that in the denominators, positive 2 and positive 6 will make the denominators 0, and neither negative 2 or 5 is positive 2 or positive 6. So these both are in fact solutions. Let's look at the next section. Since this technique should be familiar to students at this point, we will move on to a less familiar method when more than two fractions are involved. The next exercise will illustrate the process. Consider the equation 1/2 minus 9 over 4x equals 3 over 4x. What is the least common denominator for all three fractions in this equation? Well, 2 goes into 4, so we do need a 4, and then we also need an x. So our common denominator is going to be 4x. Now we want to multiply both sides of this equation by the lowest common denominator to clear the equation of the denominators, and then solve the resulting linear equation. So 1/2, I'm going to put plus negative 9 divided by 4x equals 3 divided by 4x. And we need to multiply everything by 4x in the numerator and the denominator. So our new denominator is 4x for each one. So 2 goes into 2 once, 2 goes into 4 twice. So in the first fraction we end up with 2x. In the second fraction, a negative times a positive is negative. 4x cancels with 4x, and we end up with minus 9. And in the right hand side of the equation, 4x cancels with 4x, and we end up with a 3. So to solve this, we have to add 9 to both sides, which gives us 2x equals 12. Dividing both sides by 2, we find that x equals 6. So x equals 6 is our solution. Notice that 6 inserted into any of the denominators does not make any of the denominators 0. And that's important. It is very important to note the similarities and differences between this technique and the one employed to simplify complex fractions. With complex fractions, we multiplied by 1 in a creative way. Here, we are multiplying both sides of an equation by a quantity that removes the fractional nature of the equation. Let's look at exercise number 3. Which of the following values of x solves this equation? First, let's figure out what the common denominator is. 10 does not go into 15, but 10 does go into 30, and 6 also goes into 30. So we need to multiply each one by 30. So 6 goes into 6 once, and 6 goes into 30 5 times. So this gives us 5x minus 20. In the denominator, 10 goes into 10 once. 10 goes into 30 3 times. 3 times x is 3x. 3 times negative 2 is negative 6. And on the right hand side, 15 goes into 15 once, 15 goes into 30 twice, and 31 times 2 is 62. Now we want to combine like terms. So 5x plus 3x is 8x, and negative 20 plus negative 6 is negative 26. Now we want to add 26 to both sides, which gives us 8x equals 88. Dividing both sides by 8, we find that x equals 11. 11 inserted in any of the denominators will not make the denominator 0, so the result is in fact 11. All right, let's turn this paper over. These equations can involve quadratic as well as root expressions. The key, though, remains the same, multiplying both sides of the equation by the same quantity. So our common denominator here, 5 goes into 10, so we need a 10, and x goes into x squared. So we want to multiply everything by 10x squared. So that I remember that this is negative, I'm going to change subtraction to addition and change the sign of the number I'm subtracting. All right, 10x squared. Same thing here. Change subtraction to addition. Change the sign of the number I'm subtracting. In the first fraction, 10 cancels with 10, and I'm left with x squared. In the second fraction, the x's cancel, so I have it cancel out the x in the denominator, and I have 1x left in the numerator. So this is going to be negative 10x. In the right-hand side of the equation, 1 times 10x squared is 10. Oh, excuse me. The 5 cancels with 5, and x in the denominator cancels with 1x in the numerator. So we are left with five goes into 5 once, 5 goes into 10 twice. So we are left with 2x. In the last fraction, x squared cancels with x squared, and negative 2 times 10 is negative 20. We want to subtract 2x from both sides, and we want to add 20 to both sides. This is so that we can make our quadratic equation equal to 0. We want to put everything on the left-hand side and have 0 on the right-hand side. So this gives us x squared minus 12x plus 20 equals 0. So now we need to factor this. We need two binomials. Because the coefficient of our squared term is 1, we need an x and an x. Two numbers that multiply together to be 20 and add together to be 12 would be negative 10 and negative 2. So that gives us x minus 10 times x minus 2 equals 0. So either x minus 10 equals 0 or x minus 2 equals 0. Adding 10 to both sides, we find that x equals 10. Adding 2 to both sides on this equation, we find that x equals 2. Now neither 2 nor 10 will make any of these denominators 0, so those both are in fact solutions. Let's look at exercise number 4, part B. Our common denominator, 2 goes into 4, so we need a 4. X goes into x squared, so we need an x squared. So we want to multiply both sides by 4x squared. I'm going to change subtraction to addition and change the sign of the number I'm subtracting. So 4x squared multiplied by everything. In the first fraction, 2 canceled, 4 divided by 2 is 2, and we're left with 2x squared. In the second fraction, the x cancels with one of the x's in the numerator, so we've got 4 times 3 times x, which is 12x. In the third fraction, x squared cancels with x squared, and we're left with negative 1 times 4, which is negative 4. On the right-hand side of the equation, 4x cancels with this 4 and one of the x's, so we're left with x. 2 goes into 2 once, 2 goes into 4 twice. X squared cancels with x squared, and we're left with plus 2. Since this is a quadratic equation, we want everything on the left and everything, the right-hand side will be equal to 0. So on the right-hand side, we want to get rid of the x, and we want to get rid of the 2. So we're going to subtract x, and we're going to subtract 2 from both sides. This gives us 2x squared plus 11x minus 6 equals 0. Now, we want two numbers that have a product of negative 12 and a sum of 11. So 12 times negative 1 is negative 12, and 12 plus negative 1 is 11. Now, because the coefficient of our squared term is not equal to 1, we want to use these special numbers to rewrite the middle term. So I'm going to write 2x squared plus 12x plus negative x minus 6 equals 0. And now we're going to use factoring by grouping. So we're going to group the first two and the second two terms. In the first two terms, we can factor out a 2x, and we're left with x plus 6. In the second term, we want to factor out a negative 1, which gives us x plus 6. So notice we have subtraction, and we have two terms. We want to factor out an x plus 6 and multiply it by what's left over, which is 2x minus 1. Using the zero factor property, either x plus 6 equals 0 or 2x minus 1 equals 0, which tells us that x is either negative 6 or x is equal to positive 1/2. Now, neither 6 nor positive 1/2 will make the denominator 0, so these both, in fact, are solutions. We have two examples left. Because fractional equations often involve denominators containing variables, it is important that we check to see if any solutions to the equation make it undefined. These represent further examples with extraneous solutions. So in part A, let's see, we have to solve and reject any extraneous solutions. In part A, if we factor this denominator, we're going to get x plus 5 and x plus 3. Which is what we have in our other denominators as well. So we need to multiply everything by x plus 3 times x plus 5. 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 In the first fraction, the x plus 5s will cancel, and you're left with x plus 1 times x plus 3. In the second fraction, we have to multiply. Notice x plus 5 cancels with x plus 5, and x plus 3 cancels with x plus 3. So we're left with 18 in the second fraction. On the right-hand side, x plus 3 cancels with x plus 3, and you're left with 9 times x plus 5. So let's go ahead and multiply this out. X times x is x squared. x times 3 is 3x. 1 times x is x. And 1 times 3 is 3. We still have the plus 18. 9 times x is 9x. And 9 times 5 is 45. Now combining like terms, we end up with x squared plus 4x plus 21 equals 9x plus 45. Since this is quadratic, we want to get everything on the left-hand side. So let's subtract 9x from both sides. And let's subtract 45 from both sides. So this gives us x squared minus 5x minus 24. And this is all equal to 0. We need to factor this trinomial. So we need two binomials equal to 0. We need an x and an x. Now we need two numbers that multiply together to be negative 24 and add together to be negative 5. So x minus 8 times x plus 3 will be our factors. So either x equals 8 or x equals negative 3. So let's look at our denominators. Negative 3 will make this fraction equal to 0. So negative 3 will not work. 8 will work because 8 plus 3 is not 0. 8 will also work because 8 squared plus 8 times 8 plus 15 is not equal to 0. And then 8 plus 5 is not equal to 0. So our only answer for this one is x equals 8. We have one final example. First, let's factor this denominator. We need two numbers that have a product of negative 12 and a sum of 4. So 6 and negative 2. So we already have an x plus 6 over here and an x minus 2 in this denominator. So we need to multiply everything by x plus 6 times x minus 2. X plus 6 times x minus 2. X plus 6 times x minus 2. So in our first fraction, x plus 6 cancels with x plus 6. X minus 2 cancels with x minus 2. And we're left with a 4. In the second fraction, x plus 6 cancels with x plus 6. So we're left with x minus 1 times x minus 2. In the right-hand side of the equation, x minus 2 cancels with x minus 2, and we're left with x plus 6. Now let's simplify this left-hand side of the equation. X times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative x. And negative 1 times negative 2 is a positive 2. Let's combine like terms on the left-hand side. That gives us x squared minus 3x plus 6 equals x minus 6. Because it's quadratic, we want everything on the left-hand side of the equation. So we're going to subtract x and add 6 to both sides. This is going to give us x squared minus 4x plus 12 equals 0. Now we need to factor. We need an x and an x. we need two numbers that have a product of 12 and a sum of -4. So -6 plus 2 is 12. -6 times 2 is 12. And -6 plus 2 is -4. So either x minus 6 equals 0 or x plus 2 equals 0, which means that x has to be 6 or x has to be -2. Now, looking at the denominators, 6 will not make any of these denominators 0. And -2 will not make any of these denominators 0. So they both work. Both of these are a solution to this equation. You will be successful, and I will see you next time. Bye-bye.